All right. Since we just got done talking about different parts of triangles, like angles and their sums, now we're going to talk about congruency. Congruent means two figures that are the exact same size and shape. Everything about them is the exact same. If we look at these two pictures, they are congruent. It's literally the exact same picture mirrored over. Corresponding parts. Corresponding parts are pieces of geometric figures that are in the same position on congruent figures. If you don't have two congruent figures, you can't have corresponding parts. If you don't have corresponding parts, you don't have two congruent figures. What I want to do is look at these two pictures of apartment buildings. Okay, these are pulled right off Google Sketch. It's a 3D program where you can design your own buildings and stuff. If we look at these two figures, we want to identify four corresponding parts. What are four pieces that are in the exact same position? Well, maybe you notice right away, like the entrance. Okay? The entrance of both are in the exact same spot, so they would equal each other. Another thing maybe you notice is the balcony off to the left. Okay? Corresponding parts. They're in the same position on both. Maybe you notice the walkways on the front of the building. The balconies on the front, if you will. The exact same on both buildings. Even those that are on the angle are still the exact same. And then last but not least, maybe you notice the shape of the roof. That long trapezoid. I know some of you don't know what a trapezoid is yet. You'll learn it in this class. Four pieces of both that are exactly the same. And we could have kept going. We could talk about the windows being the exact same because they're corresponding. They're in the same position on both. Let's apply that idea of corresponding to a triangle. Based on these congruency marks of these two triangles, we want to identify all the corresponding pieces. We want every piece of one to line up with a piece of the other. So let's go through the sides first of all, and then we'll talk about the angles. The first thing that I'm going to notice, or that I'm going to look at, is side AB. AB is going to be congruent to what side on the other triangle? Hopefully you're saying RS. Now, maybe you're saying RS because they're both on the left. They're both on the top and left. But I would say the RS because of this right here. Both of them have two congruency marks. And if both of them have two congruency marks, that tells me and everybody else looking at it, these two sides are exactly the same. Not only are they corresponding, they're in the same position. They both have the same congruency marks. Let's talk about BC. What side is BC congruent with? And hopefully you're saying ST because of the reason we just talked about. Not only are they corresponding, they're in the same position. Okay? Front, left, top right, whatever you want to call it. But they both have one congruency mark, which means that BC is congruent to ST. Last but not least, what about AC? AC is congruent to what other side, or what side of the other triangle? RT. Just kind of think about that. One congruency mark, two congruency marks, two congruency marks, three congruency mark, three congruency marks. They're all in the same position. The ones with one congruency mark are the top right, the twos are top left, and the threes are the bases. Not too tough. Okay. The angles. Let's talk about the angles. The first thing I'm going to talk about is angle A. Angle A is congruent with what angle on the other side? What angle in the other triangle projects in this direction, or is in this position? It's angle R, which means that angle A is congruent to angle R. They are corresponding parts. What about angle B? Angle B is congruent to angle S. They both have two congruency marks, and they both project down in their triangles. Well, process of elimination says that angle C is congruent to angle T. Not too bad. All of these are called congruency statements. Congruency statements. And when you're filling out a congruency statement or writing congruency statements, you have to do them for sides and angles. Because triangles are made up of just those, sides and angles. We could classify a triangle based on its sides. We could classify a triangle based on its angles. There's one more thing I want to talk about. Let's name both of these. Let's name both triangles. This triangle, let's name it triangle A, B, C. Look at how we went in order. We went from this corner clockwise. If I'm going to name this triangle, I have to go in the exact same order. Start here with R, go clockwise. RST. Now what I want to show you is this. If I take triangle A, B, C, and triangle R, S, T, and if I told you that they were congruent, I want you to watch this. If I write them so that their corresponding parts line up, notice how angle A and angle R are corresponding, so they were written first. Angle B and angle S are corresponding, and they were written second. What I want you to notice is you can do this. If I write them so that their letters correspond, A and R are corresponding parts. B and S are corresponding parts. C and T are corresponding parts. Not only could I do that, but I could also write it again. Triangle ABC and RST. I could also say that AB and ST are congruent. I could say that BC and ST are congruent. And I could say that CA and TR are congruent, or AC and RT. You can follow the pattern. You don't even have to look at a diagram. I could write this statement right over here. Triangle DEF is congruent to triangle LMO, LAMO, just kidding, and ask you to identify the corresponding parts. You should be able to say D and L are corresponding angles. E and M are corresponding angles. Angle F is congruent to angle O. What about sides? Without even looking at a triangle, we can do this just on the way they're written. D and E, or DE and LM. DE is congruent to LM. EF is congruent to MO. And then we could say that DF and LM, or LO, DF is congruent to LO. Just the way their letters are written tells me what angles are corresponding, what sides are corresponding. The first two in this one are congruent to the first two in the other one. Just because of the way they're written. Let's practice again. In this diagram, you're told that HIJK is congruent to LMON. Or, well, that needs to be backwards. Excuse me. Sorry about this. Quick adjustment here. Sorry about that. HIJK is congruent to LMNO. Right away, I should be saying H and L are congruent. Angle H is congruent to angle L. Angle I and angle L. Angle I is congruent to angle M. Angle J is congruent to angle N. And angle K is congruent to angle O. Right away, just based on the way they're written, I know that those angles are corresponding. What about sides? The first two letters, HI and LM. HI is congruent to LM. The second letters, IJ and MN. The third letters, JK and NO. And then we could go the first and the last. HK is congruent to the first and the last, or LO. I just wrote my congruency statements without ever being able to match up sides. I didn't have to match up the sides. Based on the way they were written, I knew what angles corresponded and what sides corresponded. Now let's say you weren't really good with that. That's fine. Let's look at the shapes. This shape, or this side, should be congruent with that side. This side should be congruent with that side because they're corresponding. They're in the same position. This should be corresponding and congruent with that, and that should be corresponding with that. Let's talk about angles. This angle should be congruent with this angle. This angle should be congruent with this angle. This angle should be congruent with this angle. And you guessed it, this angle should be congruent with this angle. And if I look, H and L should line up. Oh yeah, they do. I and M. Oh yeah, they do. J and N. Oh yeah. K and O. Oh, I'm so good. I didn't even have to look at these shapes to write my corresponding congruent theorem or congruency statements. But if you need to, you can. Now, we did all of that to do this. Find the value of x. Where is my x? It's right here. It's an angle. It's angle L. What is angle L congruent to? Angle L is congruent to angle H. Now I'm going to set them equal to each other. 6y plus x equals 102. I just replaced or substituted L with what L equals and H with what H equals. There. Now I can solve that. The only problem is I can't solve it. I have x and y. I don't know either of them. So I actually have to find the value of y first. Well, that's fine. Actually, that's not true. I'm sorry. I don't know what I'm thinking. That's correct. But the first thing I want to solve is this right here. I want to solve LM. Because that just has an x in it. LM is congruent to what? Well, LM is congruent to HI. Now I just replace both. LM is 2x minus 4. And that equals HI, which is just 8. Now I'm going to solve this so that I can get x. Once I get x, I can plug it in over here, and that'll help me solve y. 2x minus 4 equals 8. If I add 4 to both sides, they cancel out over here, and I get 2x equals 12. Well, if I divide both sides by 2, I get x equals 12 divided by 2 is 6. The reason we divide by 2 is to cancel the 2's out. I solved for x. Now I'm going to plug it in over here. Now I'm right here. And I'm going to plug in x for, or 6 for x so that I can solve y. 6y plus, instead of writing x, we write 6. And then set it equal to 102. Now I'm going to subtract 6 from both sides so that my y is by itself. 6y equals 102 minus 6 is 96. Divide both sides by 6, again to cancel the 6 out. I get y equals 16. Using my geometry to set up my corresponding parts, that helped me set up my equations that I solved. 2x minus 4 equals 8 because I knew the corresponding parts were equal. 6y plus x equals 102 because I knew the corresponding parts were equal. Using these congruency statements is a great asset. That's why we did it first. We didn't even look at the pictures or the diagrams or the shapes. Right away, we took what they told us. We took this congruency statement and immediately started pulling off the congruent parts. The sides and the angles. Then, once I got down to the diagram, I said, oh yeah, I need to find x. Well, 2x minus 4 is LM. LM is congruent to HI, and there I set up my problem. I need to solve for y. Y is angle L. Angle L and angle H are congruent. That helps me set up my equation. Those corresponding parts are what you'll use to solve for the missing pieces. And it doesn't matter if it's a triangle, or in this case, if they're trapezoids, or if, they're whatever parts. Knowing the corresponding parts and the congruency statements will help you solve for missing pieces. That's why we did it first. Let's look at this, the third angle congruency theorem, which says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent. If A is congruent to D and B is congruent to E, then C has to be congruent to F. You might say, why does it have to be? Because if A and D are the same angle, let's say A and D are, 50 degrees. And let's say that B and E are the same angle, let's say 80 degrees. Then the only other angle, there's only one other angle that will get you to the 180 that the triangle has to add up to. And so you could solve it and find out what it is. But it's going to be the same in both, every time. If you know the other two angles are congruent, the third angles have to be congruent. Every time, all the time. Let's try and solve a puzzle based on that. Here we're given a diagram. You are going to see this diagram a lot. Log it in your memory bank, put a big X by it, whatever you have to do. But you will see it a lot. We're told to find the measure of angle BDC, which is this angle right here. We got to find that angle. Well, if I look very carefully, I actually have two triangles here. I have A, this angle was angle D. So I'm going to put a little D here. And this was angle C. I also have triangle BDC. Now N was just to mark where those two triangles intersected. If I bring it back up, N is right here where those two triangles kind of cross. But I'm going to pull these apart so that I can set up congruency statements. What I want to do is I want to take triangle ABC, ADC, and I want to find out what corresponding pieces are on the other side. So what I need to do is say, what angle does angle A correspond with in the other triangle? And hopefully you're saying B, but why? Because of those little congruency marks. This angle is 45. I can see that angle A and angle B both have congruency marks, which tells me that angle B is 45, which means angle A and angle B have to be congruent. Well, now those are the only other congruency marks I have. Not true. I can see right away that this angle and this angle are congruent. If this angle is 30, then this angle has to be 30. We're going to call that angle D and angle C. Now don't get this angle D confused with this angle D. They're two different triangles here. Well, if angle A is congruent to angle B, and angle D is congruent to angle C, what does that tell you about this angle and this angle? Exactly. We can apply the third angle theorem to say that if two of the angles are congruent, the third angles have to be congruent. We can say that angle C is congruent to angle D. Now don't get those D's and C's confused here, because they're talking about two different triangles. Now we need to figure out what that angle is. I know that this is 45, this is 30, and this is x. We'll call this x. Or we could use this x because this is the one that we're trying to solve anyway. Remember BDC? Okay? We're trying to find angle BDC. I know that angle B plus angle D plus angle C adds up to how much? How much is the interior angle of this triangle? 180. Well, I know that angle B is 45. I know angle C is 30. And I'm going to use x to represent angle D. Now I can use my algebra here to solve this. So I'm going to go to another piece of paper. Make sure I wrote that down correct. Yep. Now I'm going to combine like terms. These are like terms. 45 and 30 is 75. Drop everything else down we didn't use. Now I can simplify this by subtracting 75 from both sides. (180 minus 75), well, that's 105. And I found out that x is 105. But I'm not worried about x, I'm worried about angle BDC. I used x to represent BDC, so I can say that angle BDC is 105 degrees. Notice what we started doing. We started with congruency statements, with corresponding parts, corresponding angles. That helped me set up what I didn't know. That helped me set up and say, okay, this is the missing angle that I'm looking for. I just need to actually go through and solve it now. And I used my algebra, or what I knew about geometry. I used my geometry statement here. And what I knew about the three angles of a triangle adding up to equal 180. And then I used my algebra to here to solve it. Not that tough. But that's the third angle theorem. There's one more thing that we're going to talk about, and this is a huge I told you so, okay? Huge, 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 huge. The reflexive property of congruent triangles that says that if any triangle, like ABC, can be congruent to itself, ABC, that is the reflexive property. Then we have the symmetric property, where if ABC is congruent to DEF, then you could also say DEF is congruent to ABC. You have a symmetrical statement, where it's basically flip-flopped. Then we also have the transitive property. If ABC is congruent to DEF and DEF is congruent to JKL, we can cross off what occurs twice and write a new statement, that ABC is congruent to JKL. Now, have you ever seen those before? Really? Where? Well, we saw them when you dealt with numbers in Chapter 1, with line segments. You saw it when we dealt with angles. And now you're seeing it with triangles. This is the fourth time you've seen the reflexive property, the symmetric property, and the transitive property. I told you so. You need to know these three properties. They continue to show up too. They continue to show up when we get into different types of shapes in Chapter 8. So, just a little heads up. Make sure that you know those, because you will need to use them. All right, let's do a quick review of what we learned so far in Section 2 of Chapter 4. The first thing we talked about was congruency parts, or corresponding parts. Okay? Corresponding parts of congruent shapes. That's the first thing that we talked about. Then we talked about congruency statements, where you compare the sides and angles of one shape with the sides and angles of another. Then we solved some problems using those congruency statements to help set up our problems. And that was right there. Then we talked about the third angle theorem. And we used our congruency statements to help us solve those. You're going to realize that those congruency statements are muy, muy importante. The third angle theorem. And then you had the reflexive property, the symmetric property, and the transitive property that we've dealt with 4 other times, or 3 other times. Those are the main ideas of this section. And so use what we just learned in our notes to apply it to our homework. Let's take a look at our homework now.